So good afternoon. My name's Nick. I'm from EPCC at the University of Edinburgh, and I'm talking today about our VESTEC project poster at ISC. So I don't know about you, but every time I turn on the news, it seems like there's a disaster somewhere out there in the world. And if anything, it seems that these disasters are becoming more frequent. Now, obviously, at the moment, we've got COVID-19, but even before that, things like wildfires, earthquakes, the spread of other diseases. And whilst I think it's fair to say that HPC has a good history of simulating these things after the fact, we think there's a lot of exciting potential to combine HPC with all the real-time data that's out there and put this in the hands of the frontline responders. So they can use real-time data, the HPC, not only to get a very accurate picture of what's currently happening, but also explore all the possibilities to make accurate decisions about how to tackle that disaster and save lives. Now, the three use cases that we use to drive the research and evaluate what we're doing are these three things on the screen here. So firstly, the spread of mosquito-borne diseases, which is a major health challenge in itself, but also affects Southern Europe quite heavily. Bottom left, we've got Wildfire Analyst, a commercial product developed by project partner Technosilver, who are one of the world's leading organizations for being able to model the spread of wildfires. And then lastly, on the bottom right, space weather, which can have a big commercial impact on satellites, but if you can predict it accurately, there are things you can do to limit that. So this is a high-level architectural view of the project and also where all the different project partners fit in here. So at the top are use cases, and next the front-end applications or GUIs, which enable people to visualize these things. Some are very use case specific, and some, like ParaView by project partner Kitware, much more generic. And at the bottom, we've got the HPC machines themselves, which not only have the use case specific simulations, but also more general simulations. For instance, the MESO-NH weather model, weather being an important part of many disasters. There are other technologies also involved at that level. For instance, Intel's OSPRay, which is a ray tracing package enabling very high fidelity visualization of the use cases, and Sorbonne's TTK, which enables highly accurate data reduction with no loss of fidelity. Very important. And then in the middle, we've got the VESTEC system, which connects all of this together, and ultimately all the different areas of expertise and knowledge by all the different project partners aim to enable the urgent decision responders to make the correct decision first time, every time in responding to that disaster. So we're about halfway through this 3-year project. We've got some really exciting early results. For instance, nice papers, also our first use case is integrated and running well. And then moving forward, looking towards the autumn and beyond, we're getting our other use cases integrated and evaluating what we've got. So if you want to get involved, we've got our project website, follow us on Twitter, and also a lot of the technologies we're developing will be open source on GitHub. As well as the research, we've also been looking quite in depth at the community side of things. So last year we had a very successful workshop at SC. We've got another one this year. So if you're working in a similar area or with an HPC or big data code that's relevant, then consider popping a paper into this. And all the information you need there is on the website on the right of the slide. So this is the project poster, more information on there. Thank you very much for listening. If you've got any questions, feel free to email me and I'm very happy to answer them and have a chat. And lastly, we've just got to show the ISC sponsors on this slide and also on this slide.